everyone, December 25th. All right, let's do this. Number of dice rolls with target sum. You have n dice. Each die has k faces. Number from 1 to k. Given 3 integers n, k, and target. Return the number of possible ways out of k to the n. You have n different, and each one has k. So it's k to the n total ways to roll the dice. So the sum of the face-up numbers equal target. Answer may be too large or too modulo. Alright, so basically, given n numbers, n positions, right? Each position can have 1 to k possible choices, and we want to know how many different ways. So I suppose it's different, right? Like, yes, 1, 6, and 6, 1 are different. Some sort of DP. Right, so we have, let's say 4, right? Each have whatever. It's 30, right? It's 30. So we can say if I know this one, right, and the problem translates to find the total number of ways of this, right? Then this one just goes through 1, 2, for 1 is however many, for 2 however many, all the way to for k however many, right? Which means if I know the total number, if I want to go bottom up, right? Let's say I know the total number of ways up to here for the target, right? For the target. So we can say dp I j is the number of ways. The number of ways to make j, right? And then j is smaller or equal to target, and larger equal to 1, right? The number of ways to make j given I number of dices, right? So I know this. Now the number of ways to make this. So this will be starting from 1, and then go through everything. 2 go through everything. 3 go through everything. 4 go through everything. And then we go here. Right? That makes sense, right? And we're gonna make a, maybe something like this. However many. And this is 0, 1, 2, all the way 3, all the way to whatever. 0, 1, 2, all the way to whatever. And then, what's this? First row. First row is going to be 1. How many, given 1 dice, how many ways to make 1? So it'd be, these are all zeros, right? All zeros. This is a 1. 1, 1, all the way to k, right? All the way to a k is also 1, and then the rest is all 0. Now we have 2 dices, okay? We have 2 dices. So 2 dice, right? And then the second dice can start Yeah, the second dice we can start with 1, right? And when the second dice starts with 1, the first dice can go from 1 all the way to the end, right? And then we're gonna record whatever this is, right? Whatever this is, it's going to be plus this. So pre-fill everything with 0, right? We pre-fill everything with 0. And then we say now I is equal to 2, right? And then j is actually not j. It's basically just we go through the previous j, right? We go through the previous j, and then for each one we plus 1, so we get a new one, right? Which means if the previous is 1, so 1 plus 1 is 2, right? Which means to make 2, we have one way to make 2, right? And then we have one way. This will be on 1, this will be on 2. Yeah, we go through the whole thing, and then this turns into 2. Then this won't go through 1, so 3 is actually have 2 ways, right? So you go through everything. For each one, you go through the whole thing, and then we'll update. Once we're done, we'll get a new one. Yeah, I think it makes sense, doesn't it? Now what's the end? Well, the end is because we have to go through the n. We have to go through n, so we have to this has to be n, right? And then this j basically just go to target, right? Go to target. So given this with target, okay, let's give this a shot. Seems to be making sense to me. Seems to be making sense to me. All right, let's do this. All right, so what we're gonna do is target and then k, right? Int this pre equals new int. That should be target plus 1, right? And then for int I equal to 1, I small equal to k, I plus plus, pre I is could do 1. Okay. Now I'm gonna say for int I equal to basically that's n, right? So from 2, I small equal to k, no n, I plus plus, right? And then we're gonna say is int current is new int target plus 1, right? For int j is equal to 1, j is small or equal to target, j plus plus, okay? What do? We say current something plus plus. What's this something? Well, it's going to be that's actually not right. That is not right. I think there's one more thing here. There's one more thing. It's the current. That's for int dice equal to 1, d small equal to k. Deep. Awesome. Alright, this is the dice. The current dice is Sean Dice. I think he's the coach of Everton at the moment. Alright. So this all 3 levels. So D is equal to 1. This is the dice we're gonna do, right? This is this dice. And with this dice, if the previous is this, and then that's gonna be J plus D plus plus, right? And just realize something, this has to be long. What else? This is fine. This is fine. It has to be long. Long, and we'll probably need a mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. Current is this. D is this. Shall equal to current J plus D plus previous J. Oh, my mod. Is that right? So given the current dice is, yeah, the new dice I say is gonna be a 1, right? And then the previous, we go from 1 to K. From 1 to K. That's actually not right. Well, it is go to 1 to K, but J doesn't have to go through all of them. Right? We don't go beyond. Just go beyond is not really necessary. So we can put, it's gonna be smaller equal to target minus D. How about that? Right? We go through target minus D. That's J is the previous. Right? J is the previous. Previous up into something. Right? The previous up into something. And then we know how many different ways to do it. And then plus the current. Now we have the new value. Right? The new total is the J plus D. And then we'll do J plus D, whatever it is, because we go through D different times. We might have it hit them multiple times. And then we do pre-this mod, right? So when we hit this at the end, we're going to do pre equal to current. And then go, right? Go, 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 go. Once we're done with everything, we shall return. Because pre is equal to current. Actually, we can just do current. Current, we have n, and we need to know the target. And that, I believe, is a long, so we need int this thing. Oh, that's not right. How do we do it? I think it's this. Is that right? Oh, it's outside the... That's fine, that's fine. I know. This is, we use pre. It's the same thing. Alright, let's see. Does it make sense? Index 4, out of bounds. Oh, something is out of bound. Holy crap. Huh. Alright. That is true. I did not take that into consideration. Which means this is not smaller equal to K. That shows smaller equal to the minimum. Math, the minimum of K and target. This is equal to n. Then we have to go to n, and this is also target, right? And this is 1k. If target is smaller than D, I think it should be fine. All right, let's try it again. No, Jimbo. All right. So far, so good. Let's throw a. Oh, I was going to say throw something huge. It's not huge enough. How about 31,000? This is absolutely the largest we can hope for. And it's right. So I shall be it. Yup. But it's slow. It's very slow. First time we've done this, 2019. Did I do this all by myself? In the first shot? Really? I must be very proud of myself. Yeah. Maybe. And then 2022 was the second time. 2023. Let's summarize this first. Okay, so what do we say? We say code 1155. DP where dpij is the number, right? The number of ways given to make j given I number of coins, dices. So on k and t, where t is equal to target. Okay, let's see. What else do I have? That looks easier. Look at that. Look at that. Okay, I think there is an easier way through this. I used DP the last time. There's an easier way through. We can save at least one. Okay, let's see. How can we handle this? I think there's maybe so basically we are here, right? And for each one we are adding because given this is 1, we are adding this. We're adding these things together. Given 2, we're adding these together. Given 3, we're adding these together, right? Which means maybe what we want is add a position, because now I choose the dice. I choose the dice and I put in different positions. What if we say, okay, I just want this position, give me 2. Okay, give me 2. And I don't care of how many different ways this can get. Yeah, because the smallest this can be is 1, and the largest this can be is this one minus 1, which is a range. It's a range. There is a range. There is a range. So for each j, for the new thing, right? For each j, what we can do is for this one, what we want is this one minus 1. So 1 to this one minus 1. Right? 1. Nah, hold on, because I want to make this j. Okay, I want to make this j. And the biggest the previous can get is j minus 1. Perfect. And the smallest can make, the previous can make, is because previous j minus 1 I can plus 1, and previous is 1, and I can do that. That's not 1. All right, that's not 1, because the biggest one is k. Okay, so it should be j minus k. All right, j minus k. And if j is smaller than k, then this one is 1. So it's gonna be a maximum of 1 and this. So basically from here to here, which means we can consider, it has to be, hold on. Has to be a prefix sum. All right, has to be a prefix sum. Also, we use prefix sum to speed things up. Okay, so this has to be a prefix sum, right? And if it's a prefix sum, I will more than happy just to call this target, because it's fine. Okay, because it's fine. Actually, yeah, we just go to target, right? And yeah, we go all the way to target, right? And then if it's bigger, and we're just gonna say this shall equal to pre I minus 1 plus I is smaller or equal to k, otherwise 0. Okay, now from 2 to the end, right? And now we have the current, and this is now what we do. We will directly go with here, right? So for j is gonna go from 1 to the end, right? We'd say j from this to the end. J is, we're looking at for this how many, for this how many, for this how many, right? So j from 1 all the way to target, and for each one, right, for each one, so current j shall equal to something. Okay, just delete everything. So current j shall equal to pre something minus pre something, right? So what's the biggest the pre can do? The biggest pre can do is, you know, j minus 1. That's the biggest pre can do. And the smallest pre can do, the smallest pre can do is going to be the k. And what do we say? The smallest pre can do is going to be the maximum. So mass be 1, or j minus k. Is that right? J minus 1, which is the largest pre can do, right? And then is from this plus everything. So it's a prefix sum. So it's going to be this minus, in fact, this should be minus 1, right? And it's not over yet. This is the prefix sum. And then I need to make a new prefix sum. So it has to be j minus 1 here. And what we're looking for is the target, but the target is not right. Pretty sure this should minus pre and target minus 1. That's not right. This might be negative though. So plus mod. Okay, I'll give this a shot. Is right? It's right. Prefix sum. Prefix sum. Also a prefix sum. Yep. That's the way to go, man. That's the way to go. So O and T. T equal to target. Okay. That's pretty good. Right, that's pretty good, and that's not the way. This is the way. Yeah. We know. We know how it goes. It's actually slightly different. I was going through this. Target times D. I guess both works. Makes more sense to do it this way though for me. Anyway, I call this done. Let's move on. Actually, not move on. We're gonna redo this one again. Okay. Redo this one using the DP. A better DP. It's just similar to this, but it's actually not similar at all. Okay, what is one? Binary representation of number is a power of 5. I think if I remember it correctly, what we are talking about is we have S. Right? What we want to know is the minimal number of substrings in such partition. The minimal number of substrings. So we want to partition S into substrings such that the substring does not contain leading zeros. It's the binary representation of a number that is a power of 5. Okay. And if I know the I remember. So let's say we say dp I is the equal to the minimum partition of s all the way to I. Actually, let's cut I all the way to I plus 1. All right. Then given this I plus 1, what we do is I do I plus 1 itself. Then the number of partition is dpi, right? Or I do this, right? I do this, and then I find a new. I do this, I find a new. I do this, I find a new. I do this, I find a new. Just go through the whole thing. Yep. Yeah, that's Python this thing, right? Jimbo? No, Jumba. And it's been. I need to. Include. $41. Inspired by Lee 215. Still DP, but DPI is the minimum number of partitions to create substrings for S all the way to I plus 1. Okay, and also a faster way to identify. Is it faster though? Yeah, to identify whether a binary number is a power of 5 is to test whether it is divisible by 5 to the power of 0, 1, 2, 3, 4, 5, 6, which is equal to, well, actually it's going to go Python, 5 to the 6, 15, 625, 15, 625, 15, 625. Okay. Now, we need a DP. I'm pretty sure it's len s. Yeah. So DP is equal to this, right? And DP 0. I mean, we can do DP 0 by itself. And for everybody else is basically we go forward. Maybe I don't have to do DP 0 by itself. Maybe I can just handle DP 0 with everything else. DP 0. Yeah, I think I can for I digit in enumerate s. Okay. So we say you know what? I think it's easier because here I have to check. We always have to check because you're going backwards. It should be I to the front. Current plus equal to current plus equal to sj. Well, technically it's not sj. Technically it's sj minus 0. Huh, that's not right. You have to also shift, right? Wherever it is, you have to shift, left shift. J minus I, no, I minus J. Ah. Well, control R also doesn't work. Lordy. Should be I minus J. Right? Initially it will be 0, so it will be 1, right? So S plus this. And if current is larger than div or break. Otherwise, that is interesting. So if it's equal, if I am at the front, yeah, what happened if I'm at the front? Well, if you're at the front, you should just add 1. Right? If div mod current is equal to 0. Or div mod current. If current is larger than div, or div is not, now we break. Now we don't have anything. Right, we don't have anything. Otherwise, so here we have something. Right, here is div mod current is equal to 0. Alright, when it's equal to 0, that means the current is good. So we can take the current. Oh lord, this has to be math.infinite. Right, so we take the current and dp I shall equal to minimum dpi, and here is the key, shall be dp j minus 1. Of course, depends. If j, okay, if j is larger or equal to 1, else if j is equal to 0, then we just do 1. Right, we just do 1. So we go through all of this, right? We go through all of this, and blah, blah, blah. Once we're done with all this, we eventually will have a dp minus 1, which we're going to return. I don't think I have any test cases for this written, so I don't even bother. Okay, let's try this. Solution 2 does not exist. Unsupported. Ugh. Really? Yeah, really, man. Shall we int? Integer mod. Oh, wait. Modular by, so current is 0. If current is equal to 0, or, because if current is 0, yeah, if current is 0, that means we have leading 0, right? Then we, don't do it. Can deal with leading 0. Oh, return this if dp minus 1 is smaller than math.if. Yeah, there's so many things I did not consider. That was bad. Okay. That was terrible. That's not right. Expected 2. 2 substrings. The number of substrings, dude. The number of substrings. The number of substrings is so it should be this plus 1, right? If j is larger than or 1, this. Okay, this one looks more promising. I don't know, 15. That might be longer than 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's do something like this. Do something like this. Let's do, just get a few out. Oh, that was bad. What, Jimbo? Okay, where did we go wrong? I think it's here. Yeah, hold on. There's a lot of things. A lot of things is not right. Hold on. I think I'm missing something. Current is not current, right? It's if Sj is, if Sj is equal, we do update. Okay, we do update, and we do this as well. What we did not do correctly is here. If Sj is equal to 0, okay, which means now the leading is going to be a 0, and that is not allowed. Okay, that is not allowed. And in that case, we shall continue. Right? If we have a leading as 0, that is not allowed, we'll continue, go to the next one. But we still have the current, right? We still have the current. And then we can do everything. Okay, so we basically just added this line. Now we made some changes. Let's just redo this thing. It's way too early, man and girl. It's way too early. That is O n squared, right? That is absolutely O n squared. Lordy, that was bad. Ho. Okay, something is not right. It's fine. It's fine. We'll figure it out. Maybe what we did not. Oh yeah, I think I know why it's wrong. Hold on. For one thing, so first of all, this shall happen before. Okay? This shall happen before. Okay, this shall happen before. There we go, this. And if this is break, okay, that is okay. That is okay. But here is where we go wrong. If this is equal to 0, then we do this. What it means is if the current is not divisible, we don't break. Okay, current is not divisible, it's fine. That's totally fine. We keep adding, right? We keep adding, it's okay. It's whenever it is divisible, right? Then we do the dp thing. So in that case, we're gonna make this little change. And don't forget, it's O n squared. Okay. Oh. Okay. This won't work. Yes. Come on. There we go. It's hard to do the other one, but this one is easier to reason with, right? Okay, done. That was good. Yeah, it's the same. Times 2 plus. I think that's a better idea. What do you think? Yeah, it's the same idea, but I think what he's doing is extending to extending back. Yeah, that makes sense. Hey, extending back. I'm extending forward, front. All right, so it was good. I like this problem. Next, We have 10 minutes. We can read through the problem. It's fine. Number of black blocks. You're given two integers, m and n, representing the dimensions of a zero-indexed m by n grid. You're also given a zero-indexed 2D integer matrix coordinates, where coordinates I equals xy indicates that the cell with coordinates xy is colored black. All cells in the grid that do not appear in the coordinates are white. A block is defined as a 2 times 2 submatrix of the grid. Huh? A block. A block is defined as a 2 by 2 submatrix of the grid. More formally, a block with cell xy at its top left corner contains the coordinates x plus 1, y, okay. Return a zero-index integer array of size 5 such that array I is the number of blocks that contains exactly I black cells. Let me read this one more time. So we have n by n grid, okay? And within the grid, we have a bunch of cells that are black. And a block is a 2 by 2 submatrix, okay? And we want to return an array size of 5 such that array I is the number of blocks that contains exactly I black cells. So 5, so it's 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. So in this case, I have 0, 0 is black. And we want to see how many blocks contain 0 black. That's 1, 2, 3. How many contain 1? That's 1. How many contain 2? 0. Okay. How many contain 0? We don't have any contain 0. How many contain 1? 1, 2. How many contain 2? 1, 2. How many contain 3? We don't have. Interesting. That's a very interesting problem. I have no idea how to solve this. Alright, this looks to be a good example to start. Oh my god, that's terrible. Terrible block. My god, come on. Let's draw well. 1, 2, 1, 2. Okay, so we have this is black. This is black. This is black. Alright, so the way we asked for a block is a 2 by 2. Okay, so it doesn't really matter what this is. It's always going to be 2 by 2. So we're also going to be, have this and this and this and this. We're going through. You know what? We just go it through, right? We just go through. A 2 by 2, right? With this is the first 2 by 2, right? This is the second 2 by 2. And this will be the third 2 by 2, fourth 2 by 2. So we just get 2 by 2, and for each 2 by 2, we count how many within them are black, right? How many within them are black. And we know how many, and then we put in the result, right? We put in the result. And the most is 4. 0, 1, 2, 3, 4. And that makes sense, right? Okay. So we can go through. Oh, I don't think we can go through. M is 10 to the 5th. N is 10 to the 5th. Lordy. Pairwise distinct coordinates. Which means I cannot just go through. Because you go through, that's MN, OMN, right? OMN times 4. That's the naive solution, OMN times 4. But it's not going to work. It's not going to work. It's on timeout. So I have to think of something smarter than this. Okay. Yeah, we can figure something out. How? Let's say Dude, how do I do this without? We can know, right? We know where the black cells. We know where the black cells are, and that's 10 to the fourth of them, black cells. And I was going to say, I mean, the blacks on the first row only affect, right, those. What does that mean? Right, what does that mean? It doesn't mean anything. In the second row, so we cannot just go through everything, right? No, that's not gonna work. We cannot go through everything. We cannot count we know the total number of blocks. Okay, that we know. What does that do? The total number of blocks. Well, I don't really do. It might help, right? It might help. Because we are asked for is how many blocks has 0, right? How many blocks have 0 blocks? And zero blocks. Like it's an area where there's no black cells. Or we can say each occurrence of a black cell, right? If the black cell happens in the center where it's surrounded, then like we have 4 of them does not. 4 of them does not have. They all have a black cell. Maybe it's like that. For each one we count. Does that make sense? For each one we count how many it's gonna affect. Well, but we will have overlap. Yeah, we can say for this, we'll have 1 that contains 1. And for this, we'll have 1 that contains 1. And for this, we have 4 of them contain 1. But then 2 of them is actually containing 2. And that's... What if we can sort the blacks? You know, like coordinates, like if x is equal to, well, maybe y is equal to 0. The first row, okay? If I have first row, okay, let's say y is equal to 0. I know the x's, right? I know some x, okay? Y is 0, I know some x. And then y is equal to 1. Because that covers y equal to 0 and a y equal to 1 covers the first row of the block. Right? That makes sense. Y is 0 and a y is 1 covers the first row of the block. And we have all the blacks just within this one row. Okay, within this one row, I know where the x's are. And let's also say the x's are all sorted. Okay, so for y equal to 0, I have a list. For y equal to 1, I have a list. And these are sorted x, x 0, 0, 0, 1, da, 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 x 1, 0, x 1, 1, da, 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 right? We have all these. Now what? Now, can we use these information to figure out how many blocks on the first row of the blocks, how many of them has, yeah, you know what I mean, right? You know what I mean. I guess it's a yes, but I need still a little bit more intuition here. Okay, I need more intuition here. So basically, it's two sorted list. Okay, it's two sorted list. Maybe we can compare, right? The top, the first one, and the second one, right? The smallest. So basically, we compare the first block on the first row and the second block on the second row. And if they differ by smaller or equal to 1, right? That means we have a block. We have a block that contains 2. Okay. And then the smaller one move forward, and if it's still different by so like the condition is going to be like we have some x0 p and x0 x1 q, right? And these are all the smallest. So the situation is going to be, if this is smaller than this, or this is equal than this, or this is larger than this. There's only 3 possibility. If this is smaller, then we know, because we have 2 rows, right? If it's smaller than this, well, there's actually more, because it has to be smaller than this minus 1, equal to minus 1, equal to plus 1, larger than plus 1, right? So I can have this is x0p, and someone here, x1q, all right? This is y equal to 0 and y equal to 1. And in this situation, what I can say is they are more separate apart, which means we have one block has one block. Okay, so this one has one block, and we can move forward. Oh, that's not right. That's not right, because the second one can be right here. Dude. Maybe we should analyze it, row by row. So the first row, right? If I have a block, and then I have a block, skip, I have another block, right? In this case, I know the index of each block. Come on, I know the index of each block. It's from 0, 1, 2, 3, all the way to n minus 2. Okay? These are the indices of the blocks from 0 to n minus 2. These, done deal. 0 to n minus 2. I know that, right? I know that. And I go through the first row, then I know which one has to count 1. Right? 这样吧。 I know which one has count 1. Then I can say count 1 for this row, right? I can have a list with 0, 1, 2, 3, 4. So for this row, I can use top left corner to represent, okay? Top left corner to represent, right? And then I say, okay, I know for this, that's actually not right. I need a thing which it goes 0 all the way to n minus 1, n minus 2, right? So if this one is count as 1, I mark it, count as 1. In this case, count as 1, right? And then we move down to this one. But we don't do it this way. We go through these indices. So we go through this index, so we know it counts as 1. Yes. So for each index, for each x, right? For each x, it belongs to 2 blocks, right? It belongs to x. It belongs to x minus 1. It belongs to two boxes. So for this, I'll just increment this by 1. For this, increment by 1. And then when I call this, yes, we go through all the x's, then we record how many it is for this row, right? How many it is for this row, right? We know how many it is for this row. How many it is for this row? Well, technically, we probably will save us time if we use a dictionary for this, right? We just say the x coordinate, right? This one plus equal 1, like a counter, right? Like a counter. Doesn't matter, right? Wait, plus equal 1, plus equal 1. And then we go through the next row. We try to find the coordinates, the next coordinates, right? The next row of the coordinates. And if the next coordinates has the y is the previous plus 1, then we have to go through it again. And that can help us, right? Go through the entire thing. And then we will know within this row of block, right? Within this row of blocks, how many blocks are there that have 1, 0? No, we don't do 0. Have 1, 2, 3, 4 different. Okay, Jimbo. Yeah. Yeah, so we go through them, 2 times, 2 rows. And then after we're done, we go, I still feel like it will still take a lot of time. That's what I'm afraid of. Yeah, we have a row, we get these blocks has 1, and then got a second one, we got these blocks has 1. And then combine them, then I know, okay, these blocks, like this block has 1, this block has 2, this block has 1, this block has 2, so we have to collect all of them, right? We collect all of them, and then as we collect all of them, we will reflect it into the answer, right? We'll reflect them into the answer. Okay. And then we have a new one. Okay. Yeah, it might work. But let's save the implementation tomorrow. What shall we say? Let's save this implementation for tomorrow. Alright, I'm gonna end right here.